Alright, so we've done vector addition, and right now we're going to do vector subtraction. So that's only 24D. 24E and F will be on another video. Alright, so vector subtraction. To subtract one vector from another, we simply add its negative. So you can also say there's no such things as subtracting vectors from each other. To review, you guys, when you're adding two vectors, let's say this is vector A, this is vector B. To add vectors, you simply align them by head to tail, okay? And the displacement is this, A plus B. So head to tail, and the displacement is from the beginning up until the end destination. So vector subtraction is simply adding its negative. So here's the thing. People tend to just, okay, I can just rotate stuff, right? So for example, if I were to show A minus B, people would think, okay, that's easy. I'll just, rotate this around. So let's see. I'm going to do this, and then I'm going to rotate it somehow, like just rotate it like this. Let's see, that's B. And then, just cut it off. So it doesn't work that way. Because, first of all, this arrow would not be B. Vector would not be B. Because, again, a vector is, the components that are important for a vector is magnitude and direction. So this here might be the same magnitude as this vector here, but the direction is completely different. So you could say this is probably northwest, and this is probably northeast. Completely different vectors. So that's not a go, right? So what we're doing actually, we're just adding the negative. So A minus B, again, you start with A, vector A, okay, and then you add B, okay. Since we're subtracting, we're gonna add the opposite of B, so the opposite direction. So that would mean this vector here. So that's it. And again, the displacement would be here. We're starting from the same beginning, and then we're ending at the same point right here. And that's it. So let's do an example here. So they say find S minus T, given that S is this arrow here, and then T is this arrow here. So we want to subtract them. Okay, so on your graph paper, remember that each vector has a horizontal component. So how many units do they go from left to right? And then a vertical component as well. So let's draw S first, because that's where we begin. So S has 3 horizontal components. So let's do this. And then vertically, it is also 3 units up. So I'm gonna connect them. Remember, it has to be this direction here. So this is S. Okay. And then T, it is pointing, okay, north. Never eat sour watermelon. T is pointing towards southeast here. So southeast. And S was pointing southwest. Okay. So north is pointing this way. How many? 2 units as its vertical component, and then 3 units as its horizontal component. So this is t, right? So from the previous subchapter, this would be s plus t. Okay, but this example here is asking us s minus c. So that means we need to do the opposite direction so we can have the negative of t. So again, that would mean it would look this way, would go this way. Okay. Again, the horizontal component is 3. So let's pretend there's another box here. Okay, 1, 2, 3. And then up 2. Okay, 2. So it'll be here. So 3 and then 2. Again, they would have the same magnitude, but since this is a different direction, this is negative t. It's the opposite direction of t. Okay, so if t was southeast, then negative t would be northwest. Do you see how it's opposite of each other? So yeah. So how do we find s minus c? Again, it's the same thing. You start at the same place and then you end together as well. There you go. So this is s minus t, or s plus negative t. Easy, right? Alright, so let's do another example. So this one's a bit different here. Okay, so they say for points P, Q, R, and S, simplify the following vector expressions. So for the first one, it says vector QR minus vector SR. But they didn't give us any diagrams or any vectors, any pictures here, right? So let me show you how to do this. So it doesn't matter. So that means doesn't matter the units. They just want to know what the result of this, right? And we expect a vector coming out of this, right? We just don't know what letters. And this one as well, we expect a vector as the result. Because it makes sense, like, you know, the usual math problem. If you're talking about oranges, you're dividing the oranges. How many oranges do people have? It's the same thing. It's the units here, you may call it. Okay, so remember what this means, right? So that means we are starting at Q, and then we're ending at R. We emanate at Q and then terminates at R. The tail will be on Q and the head would be on R. Okay, and then they say minus SR, the vector SR. Okay, remember that subtracting a vector is the same thing as adding the opposite. Okay, so the opposite of SR is RS. We don't know the units, so it's okay if you just, you know, draw any vector, but label them, okay? So RS. Okay, so that means, so if this were QR, and this is the opposite of SR, the opposite of SR is RS, that means QR plus negative SR is QS. As easy as that. You can also spell it out like QR plus negative SR Or you could also simplify it as QR, the vector, plus RS. Yeah, easy. So I want you guys to do this one first. So this is your answer here. I want you guys to do that first. Same thing as the first one. Okay, so this is what you do again. We're going to start with Q and we end at R. So, and then the arrow head. Okay, you can also label it for your own benefit. Okay, and then again, the opposite of SR is RS. S, okay. Okay. And then it says also minus PS. And as you guys can guess, minus PS, or the negative of PS, is the opposite direction, right? So it'd be SP. So that means we have another point. Let's make it, I can do it here. So yeah. So what's the result of all of these? We're adding all of these vectors. So your answer should be QP. There you go. So that's it for today, for this week actually. So we're going to take a quiz on Friday, but make sure that you know how to operate with vectors so far. Alright, see you guys in class.